Today we're going to work on proving similar triangles by side angle side and side side side. Yesterday we looked at angle angle as one of the ways that you can prove two angles are similar or two triangles are similar without looking at all sides and all angles. Today we're going to look at the other two ways that you can prove two triangles are similar. So the first one we're going to look at is called side side side, or abbreviated SSS. And basically what it's saying is that all the sides from one triangle are proportional to all the sides in another triangle. So let's start off with just a triangle. Say triangle ABC, and let's say this side is 8, this one is 12, and this one is 16. So what we're going to do is we're going to look and see if a couple of triangles are similar to this one by side, side, side. So the first one that we're going to look at, we're going to say is triangle DEF similar to triangle ABC. All right, so first we have to have a triangle to look at. So we're going to look at this triangle here. So this is D, E, and F. And let's say these are sides 6, 9, and 12. And basically we want to see if all three sides of this triangle are proportional to all three sides in this triangle. So when you start to go through and do this, again, side, 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 it's only if you know all your sides to it, you'll be testing this one out. You kind of have to have a method to make sure that you're matching up sides correctly to it. So one way when you have all three is you can go and say, you want to go through and compare the ratios. And you want to go through and kind of have some sort of method to be able to go through. Let's say if we want to do, maybe the short side and compare those first, and then maybe the longest side, and then maybe the other side. You have to have some way of kind of organizing these. So let's say if I do the shortest side on this one first over the shortest side on this one. So the shortest on this one is 8 on top of the shortest one on this one, which is 6. And we want to compare that to the same thing. So we're going to do longest side now. So again, if we started with this one, we have to keep starting with this one. So it's going to be 16 over the longest side on this one, which is 12. And the other side that we haven't used on this one is 12. And the other side that we haven't used on this one is 9. And you want to look and see if they're all proportional to each other. Well, 8 over 6, you can divide each one of these by 2, and that one comes out to 4/3. This one, we could divide each one by 4, and that would reduce to 4/3. And this one, we could divide everything by 3, and we also get 4/3. Since all three ratios are exactly the same, that means that these two triangles are similar. So triangle ABC is similar to triangle DEF. Okay, and that's by side, side, side similarity. Okay. Now, if you know all your sides, you can set them up this way, which might be easier for some of you. You can also go through and find the matching parts to it as well. Like for instance, on here, our shortest side is A to B, so our shortest side over here is D to E. And notice how those two match up, just like all of our other similarities have matched up as well. Okay, let's try one other one. So let's say, is triangle GHI similar to triangle ABC? So let's have a new one here. And let's say JHG, so 10, 8, and 16. Okay, so we're going to do the same kind of thing again. So I'm going to do short side, long side, other side. Well, and I'm going to go through and compare it back to this one right here. So again, my shortest side on this one was 8. Shortest side on this one is 8. Longest side on this one is 16. Longest side on this one is 16. The other side on this one is 12. And the other side on this one was 10. So 8 over 8 would reduce to 1. 16 over 16 would reduce to 1. And 12 over 10 is not going to be equal to 1. That's going to reduce down to 6 over 5. So because all three are not exactly the same ratio, it means they are not similar. Okay, so you'll want to go through and check, especially if you're doing side, side, side. You're going to want to go through and check all of them, because just checking 2 of them could show you they're similar, but you have to check all 3. Right, let's look at some where you don't actually know all of the sides. You might have some that are variables too, and you're trying to determine what they are. So let's say that we want to find the value of x that makes triangle ABC similar to triangle DEF. Okay, so let's draw out some triangles here. So A, B, C, 4, x minus 1, 8. Let's say D, E, F. Let's say 12, 18, and 3x plus 1. Okay, so for this type of problem, I can't go through and look for the longest and the shortest, because there's 2 sides because I don't know what x is, I don't know if it's bigger or smaller than those other sizes. So in these, you have to go through and use your similarity statement. So you want to pick one of your sides that deal with x, preferably probably whichever one is easier to use. I'm going to choose this one. This one's definitely on the easier side compared to this one. So this is side B to C. Now, when I use my similarity statement, B to C was these last 2 for this one. So that means that has to match up with the last 2 on this one. So the E to F. Well, my E to F is at 18. Now, for your second one, you want to go through and figure out which side actually matches where you have a number and a number, because you don't want to end up making it something harder than you need to. So let's say this side is A to B. Okay, and that's just a 4. See if that matches D to E. Well, D to E is also just a number, so I can use those 2. So I can use A to B over D to E. And you don't have to write this step. For some, it kind of helps to be able to write out which parts match which, so that all you have to do is fill in the numbers. So B to C was x minus 1. E to F was 18. A to B is 4. And D to E is 12. So now all we have to do is cross multiply. So 12 times x is 12x. 12 times negative 1 is negative 12. 18 times 4 is 72. So we add 12 to both sides. So I get 12x is equal to 84. Now I just got to divide by 12 to both sides. And I get that x is equal to 7. Okay. And you can go through and double check once you have those that it does actually work. So if x is equal to 7, this is a way you can self-check yourself. If x is equal to 7, that means that this side is actually 6. And this side, 7 plus 1 is 8. 8 times 3 is 24. All right, and we can just kind of go through and check our proportionalities. So side A to B is 4 over side D to E, which is 12. Side B to C, we know is 6. And E to F is 18. And then A to C is 8. And so that'd be D to F. And D to F we know is 24. And all of these, 4 over 12, 6 over 18, 8 over 24, all reduced down to 1/3. So that means they are all proportional. So those are all side, side, side similarities. Now we're going to go through and look at the other one, which is side, angle, side similarity. Okay. So side, angle, side similarity. It's basically a side, angle, side. This is the last similarity for triangles. Now, for this one, you have to make sure you're careful. It's not just any two random sides and an angle. The angle has to be between the two sides. So the angle must be between the two known sides. Okay, so we'll look at a couple examples. So just kind of a visual, I guess, first. So let's say I have two, let's say this is X, Y, and Z, and N, and P. Okay, so if we have two angles that we know are the same, remember we talked about those marks a little bit yesterday. So those two angles are the same. So angle X, remember an equals with a squiggle is congruent, or the same as angle M. Basically, for this to be able to work, we have to have the two sides that are next to the angles. Okay, so for example, X to Z, okay, X to Z would have to be proportional to M to P. And the other side, X to Y, would have to be proportional to M to N for this to be able to work. So let's go through and look at a couple examples of these types of problems. Okay, so let's say, is triangle SRT similar to triangle PNQ? All right, so let's draw them out. So this is 24, 28, T, R, S. Let's see, Q and P. This is 18 and 21. All right, so first off, just by looking at this, I can see that they both have a right angle, so they have an angle in common. So angle R is congruent to angle N. Okay, so we have that portion of it. Now we have to check and see if the sides are proportional. Remember, this has to be the two sides touching the right angle, which it is for both. So since we actually know what these are, we can do maybe short first and then long. So the short side on this one is 24 over the short side on this one, which is 18, and see if that's proportional to the long side on the first one over the long side on this one. Well, 24 over 18 would reduce to 4/3, and 28 over 21 would also reduce to 4/3. So that means that these two triangles are similar by side, angle, side. Okay, so you just have to check those. You got to make sure that the angle in between is the same. All right, go through a couple others here real quick. Let's say if triangle DEF is similar to triangle PQR, we want to go through and find X. So these can be just a little bit more challenging. So let's get them drawn. So F, D, E, P, Q, R. So X, so this one's 20 degrees, 20 degrees, 6, and 9. All right. My recording device only lets me record for 15 minutes, so I'm going to have to stop this video, and I will pick right up on this question into the next video.